Hello everyone. Today we'll discuss the lab set program, that is your RSA program. So here the question is write a program for simple RSA algorithm to encrypt and decrypt the data. So here, before proceeding, this RSA algorithm in networking, there's some concept called as network security. In network security, there's a topic called as cryptography. In cryptography, this RSA algorithm will come. So what do you mean by cryptography? As you know that it is provided for security purpose. Whatever the message you are going to communicate between your sender and receiver, in order to prevent from unauthorized user or malicious user. Okay, in order to protect your data, you're using a technique called as cryptography, and one more technique is as signography and everything. Before that, what do you mean by cryptography? It just says that it is one of the method where you're going to go with a process called as encryption and decryption of the message. So what does it mean? So before sending the data to your network, you're encoding the data. Okay, you're encoding the data, and that encoded message has been transmitted in your network. While you receive the data at the receiver, you need to decode the data. So before that, you need to know some convention. Okay, there is something called as plain text, something called as ciphertext, that is the encoded message, or you can say the transform message. Or even though you can, if you see the ciphertext, it is unable to specify what the message is. Why? Because it is converted, it is encoded to some other form. That's it. So here what happens is the encryption, whatever it is there, that you're going to perform at your sender end. Means the sender, what he's going to do is, before transmitting it to your network, is going to convert the plain text to your ciphertext, and this ciphertext is sent in your network. Okay, so what do you mean by encryption? Encryption is done at sender end. The process of converting the plain text to ciphertext by using a key is called as encryption. Encryption is done at sender end, and you are sending this data. And at the receiver, what you need to do is you need to go with a process called as decryption, or also called as decode, the process of converting ciphertext back to your plain text, again with a key. So this is about your decryption. So in your cryptography, you come across these two concepts, main two concepts, that is your encryption and decryption of your message. So before, like how exactly it works, let me show in this diagram. So sender, what is going to do is, whatever the message, original message you want to convey, okay, into your network, whatever you want to feed into your network, in order to receive by the receiver, what is going to do is not going to send the original message as it is. Why? Because the interceptor or the hacker can hack the message, and it is able to see all the messages. He is able to see all the message. In order to provide the security, what you will do, the plain text is converted to what? Ciphertext. How is been done, Andre? At the sender end, you are performing encryption. Encryption algorithm is performing. So what does it do? Encryption, the plain text is converted to ciphertext by using an encryption key. By using an encryption key, and the ciphertext is sent. Whenever the ciphertext is sent, even though the hacker is going to hack the message, he is unable to see the message. Why? Because it converted to some other form. It can be watermark, or it can be converted to some other characters, or numerical special characters, whatever it may be. There are different types of encryption algorithm, and it has been received by the receiver, and you can't identify what is the ciphertext. So, receiver, what he has to do is, he has received the ciphertext. So what he has to do is, he has to go with a concept called as decryption. So what do you mean by decryption is nothing but the process of converting the ciphertext back to plain text by using what? Your decryption key. By using your decryption key. So this is how the cryptography work. So here, the lab set program, what you're going to study, RSA, is one of the cryptographic algorithm. It is one of the cryptographic algorithm. So before proceeding, the types of cryptography, the two main techniques here. Normally three techniques is there, but main techniques, whatever it is, the types of cryptography, whatever it is there, it is two type, namely symmetric key cryptography and asymmetric key cryptography. And as I said in your previous diagram, if you want to perform your encryption nor your decryption, For both the cases, you need key. So here the two types of cryptography are there: symmetric, asymmetric. Symmetric, as the name only says, symmetric, same, means the same key is used for encryption as well as decryption. Nodi. Secret key is also called a symmetric key. Symmetric is also called a secret key cryptography, which uses a same key or a single key for both encryption and decryption. That is, your private key only is used. Okay, what is the difference? Again, there are two types of key: private key and public key. Private key andre which is only known to the authorized person, a unique one. A private key which is known to anyone, and public key which is shared publicly, known to everyone. That's it. So here, asymmetric, name indicates asymmetric, different. So here, asymmetric key cryptography is also called as public key cryptography. What does it mean? You're using one key for encryption, one more key for decryption. So you're using public key for encryption and private key for decryption. That is your public key cryptography. Now your RSA algorithm, whatever it is there, whether it is symmetric or asymmetric, your RSA is asymmetric key cryptography. As the name only says asymmetric, what does it say? You are using two different keys. One is your public key for encryption and private key for decryption. And now we'll discuss how exactly your RSA algorithm will work and why RSA. The RSA, whatever it is here, it refers to the scientist. Okay, three people: Rivest, Shamir, and Adelman. Okay, so they invented this algorithm in 1982. That's why it is named as RSA. Rivest, Shamir, and Adelman. Okay, and this is what type of cryptography is? It is public key. It is also called as what? Asymmetric key cryptography. Means what? Users, it is going to use different key for encryption and decryption. So here what happens is a sender, okay, so whenever it's converting plain text to your ciphertext, so what he's going to do is he's going to use public key. He's going to use what? Your public key. And whenever you're going with a decryption, for converting from back from ciphertext to your plain text, you're using what? Your private key. So that's what we can say how exactly your RSA algorithm will work. Means you're using what you can say is different keys. You're using your different keys. One key for encryption, the other key for decryption. Means here in your RSA algorithm, what you're doing is you're using public key for encryption and private key for decryption. Public key is known to everyone. Private key means only the authorized person knows. That's it. So your RSA algorithm is what? It is asymmetric key cryptography, or you can also call it as public key cryptography. And now we'll discuss how exactly this particular algorithm will work. Okay, this is your algorithm. Okay, totally 6 steps are there. Okay, first step, what I said is choose two large prime numbers, P and Q. Okay, so here what do you mean by prime number is nothing but the number which is divisible by 1 and itself is your prime number. Example 3, 7, 9, 11, 13, 17, 19. This is all your prime number. Why they say large prime number? As you know that you are using your key in order to generate your private key and public key. If you use a large prime number, it would be very difficult for a hacker to guess the keys. That's why larger the prime number, more secure it is. Okay, this is your algorithm. Take two prime numbers and find the product of two numbers, that is P into Q, and you need one notation pi. How you're going to calculate is P minus 1 into Q minus 1. So these are the general steps in order to calculate your public key and private key. Okay, as soon as that public key is needed for encryption and private key is used for decryption. So what you're doing is, in order to calculate your public key, you're using this formula. So GCD, greatest common divisor, E comma pi. So pi you will get by the prime numbers whatever you've chosen, and E what you will do is you keep on putting some number. Whichever satisfied the value equal to 1, that number whatever it is, that will be your public key. I'll show you with an example. And the same way, by using your public key, you're calculating your private key. See, E star D minus 1. This is a formula. Mod pi already you got by using your prime number pi value. If it is equal to 0, whichever value that is going to satisfy for equal to 0, that will be key, that will be your private key, that is your D. That's it. So now it is simple. So what you will do is M is nothing but the original message. So sender, what is going to do is going to convert plain text to ciphertext. So how do you get ciphertext? C is nothing but ciphertext. How do you get ciphertext? For your virtual message, what key you have to use? Encryption, public key, that is your E, M power E mod N. Whatever you do, that you will get your ciphertext. And the ciphertext, whatever it is, it is been transmitted from sender to your receiver. Then what the receiver will do is, again, in order to see the original message, he has to convert the ciphertext back to what your plain text. So P is nothing but plain text. By using your ciphertext, what the receiver will do is you'll use your private key. Private key is nothing but D, C power D mod N. So again, you'll get what? The original message back. So this is your RSA algorithm. This is your RSA algorithm. And now, how exactly this algorithm will work? We'll take some simple example. I'll take prime numbers as 7 and 3. P is 7, Q is what? 3. And suppose just message whatever I want to communicate is 9. I'll take some integer number. So you can give in your program, you can give whatever the message you want. Okay. So second step is what? Find the product of two number. That is N is equal to P into Q. That is 7 into 3 is what? 21. Next, you're calculating a pi value. That is P minus 1 into Q minus 1. So P minus 1 is 7 minus 1 is 6. 3 minus 1 is 2. 6 into 2 is how much? 12. That is your pi value. And now you need to calculate your public key and private key. And the formula, what is, how do you calculate your public key? Public key is denoted as E. Okay, convention, that's it. So GCD of E comma pi equal to 1. So here, what you're doing is you're taking the value of E, you're putting it from two value. Why? Because one, if you use, one is universal prime. That's why for all, one will be satisfied. So leaving one, I'll apply from 2. Okay, I'll apply from 2. Whether GCD of 2 comma 12 equal to 1? No, it is 0. So this is not 2, can't be your public key. So you keep on applying like this. So whichever that is going to satisfy the condition, that will become your public key. So now GCD of 3 comma 12. So 3 comma 12 means 3 4 is 12. So it is 0. It is not equal to 1. This also, it is not satisfying for even for value what? 3. So next you will go for 4. 4 comma 12 and again 4 12 0 it comes. So this also is not satisfying the condition. Next 5 comma 12. Yes, 5 2 is 10. So 2 2 is 4. Yeah, 1. So GCD of 5 comma 12 is satisfying. So that is equal to 1. For whichever the value that is going to satisfy, that you're going to choose as what? That you're going to choose as your public key. So that is your E. E equal to which value? For which value it is satisfying? For 5 it is satisfying. So I'll make that as what? Your public key. By using this public key, what I'll do? I'll calculate the private key by using this formula. E star D minus 1 mod pi equal to 0. Again, here also what I'll do? I keep on putting the value D from 2, not 1. Okay. So you can see, I'll apply 2 value. 5 star 2. E you got already. E value is how much here? 5. 5 star 2. That is 10 minus 1 mod pi. Pi is how much I got? 12. So 5 star to 10 minus 1 is 9. 9 mod 12 equal to 0. No, it is 9 only. False. It is not satisfying the condition. Next you will go for what? Value 3. 5 star 3. 15. 15 minus 1 is 14. 14 mod 12. 14 mod 12 equal to 0. No, it is 2. Next value I will give 4. 5 star 4. 20. 20 minus 1 is how much? 19. 19 mod 12 equal to 0. No, it comes 7. Next you will go for the value 5. 5 star 5. 25. 25 minus 1 is 24. 24 mod 12 equal to 0. S. Whichever condition satisfies, that will be your public key. For which value it is satisfying is E, that is your 5. So your public key, sorry, your private key, whatever it is there, your private key, whatever it is there, that is which one here? That is your, 1 second. So your private key, so that's your D, whatever it is here, it is being taken as what? 5. So by this you got what? Your public key also you got 5. Private key also you got what here? 5. So now what you need to do is you need to go for your encryption and decryption. You need to go for what? Encryption and decryption. So how do you do that particular thing is again here. So you got public key and private key. Now How do I calculate? See, assume that your original message, whatever you want to transmit, is 9. So what you'll do, the formula used. So in order to get your ciphertext for your message, you'll use what? Public key encryption you are doing. For your message, you are using which? Public key encryption. Mod n is a formula. So m is what? 9. 9 mod. What is your public key you got here? E you got as 5. So 9 mod 5 mod 21. You need to check. How do you check this mod function? 9 power 5, you will get what? 59049 mod 21. You will get 18 value. How do you get this 18? I'll show. So 9 power 5 is how much here? 59049 divide by 21. You will get something like 2811 point something. You take only the decimal part. 2811 into 21 you do. You get something like 59031. So 59049 minus 59031 will get what? 18. So the mod function is calculated like this. I'm just showing. So here what happens is the message is 9, but whenever you do your encryption, what happens is this plain text, whatever it is converted to what? 18. So you're sending 18 in your network. Even though the hacker is going to act a message, you'll get 18, not 9. You'll not get the original message. Now at the receiver, he has got 18, but that is not your original message. So what he has to do is he has to go for decryption. So the ciphertext has to be converted to your plain text back. That's your decryption. So plain text, how do you get on there? For your ciphertext, you need to use what? Private key. What is your private key is, according to this particular formula, private key is D. D also you got as what? 5. So for C power D, that is ciphertext is 18. For ciphertext is your 18. For this particular ciphertext, what you will do is 18 power for D value is what? 5. 18 power 5 mod 21. N value, how much you got here? N value, whatever it is, N value 21 is there. So 18 mod 21 you will do. 18 power 5, you get 1889568 mod 21. You need to get, see again, whenever you go with your decryption, you need to get what? Plain text back. That is your 9. So we'll get or not, we'll see here. So 18 power 5 is 1889568 divided by 21. You'll get 89979 point something. You take only decimal part, that is your 89979 into 21. You get 1888559. So 1889568 minus 1889559, you get 9. So hence proved. See, for your original message, ciphertext is 18. Again, if you do decryption, you need to get what? Your 9 itself. So you are getting this. So according to this, whatever I explained, how exactly your RSA algorithm will work. Hope you are clear with this, guys. So now, before proceeding how exactly it works, I'll show you algorithm. So this is your algorithm. So simple thing. So your RSA algorithm program in Java. So what exactly you're doing? So we'll go with your main function. Okay. So you're taking prime value P and Q. Okay. And N value you're taking E. That is your public key. D is your private key. Pi unit. So these are all the variables I'll initialize. And I'll initialize one array, num message, and one encrypted array, decrypted array. Okay. So now what I'll do, I'll use your scanner class in order to read the input from your keyboard. Okay, for reading your prime value, for reading your message, for all those things. So first and foremost thing is enter the message to be encrypted. So by using your scanner class, what is your scanner class? Object SC. So by using your scanner object, next line is a method. Okay, in order to read the input in the format of string. What is the difference between next and next line? Next line doesn't read the spaces. Next line will read the spaces also. Whatever the message you enter, it will be stored in a variable called as what? Message. It will be stored in a variable called as message. Next, what you will do, you need to enter two prime numbers, that is your P and Q. So I'll read by using your next int method. It takes the integer method, stores in your P value. Again, read one more prime number, store in your Q. Same like algorithm. See. So next you will find the product. So N is equal to P into Q. Again, pi you are going to calculate P minus 1 into Q minus 1. Okay, and just I'm printing that. Okay, so then what I'll do is, so in order to calculate your I value, that is your E value, that is your public key, how do I do that? And then see, I will start from 2. Why? Because 1 is universal prime. I'll start with 2. Less than what? Less than your pi value. It should be between that only. So GCD of D, the same formula. E comma pi equal to 1, it has to satisfy the condition. So from 2, keep on putting the value. Whichever the value that is going to satisfy, that I value will be copied to which one? E. So that would be your public key, and you are printing that. And in the same way, you are calculating your private key. The formula is what? E star D minus 1. See, again, the D value I'm applying from true. So you are using your for loop. E star D minus 1 mod pi equal to 0. Whichever the condition that satisfies, that will be your private key D. I'm printing that one. So hope you're clear with this. So next what you'll do is, so I'll just run and I'll show. Okay, so here I'll run my program. Okay, I'll just give enter the message to be encrypted. I'll just give hi. Okay, and prime number it is asking. I'll just give 7 and 3. See, I value is what? 12. E value I got 5. D value I've got as 5. I took the same example, 7 and 3. See, now for encrypted message HI, it is converted into what? 8H and 18R. It is converted into what? 8H and 18R. This is your encrypted message you're going to send. Again, it has to decrypt and get the same message, hi itself. See, you're getting the proper one. Now, let me see how you get this 8H and 18R. 8H and 18R. So here, see, for I is equal to 0, I less than message dot length. Message you are giving something like true. Yeah, it is true. I less than 2, it is true. You come here, message dot character at I. So what this will do is, okay, message is in the format of string. I variable is in the format of integer, typecasting. So what it does is, whatever the message you're given is going to calculate the ASCII value of that particular thing. Under ASCII value, under if you just here. Okay, so here small a is having ASCII value as 97, B is having 98, C is having 99. So these are the ASCII values for your alphabets, whatever it is here. So now I'll just give what? Hi alpha, HI. H and I'll give. So what is the ASCII value of your H is 104. So here in your program, what exactly it happens is, see here, where it is here. Message character at I, and the first one H I've given. So it's going to do typecasting and it's going to calculate ASCII value of your H. That is 104 minus 96. That is what? 8. That is stored here. And again the same way for I. I and what is the ASCII value for I is 105. 105 minus 96 is how much? 9. So 9 is stored in num message of 1. Num message of 0, it is 8. Num message of 1 is how much here? It is 9. And then it is going to store the ASCII value. Next, what you will do is, you are going to store that particular length in a variable called as number of element. Okay, and you will go this way. Encrypted of I equal to 1 you will take. And here, this J loop, whatever it is here, this is your J is equal to 0, J less than E. And the E, what it stands for? E stands for your public key. And here, what you will do is 8 power E is how much? 5. 8 power 5 mod N. 8 power 5 mod N. And the 8 mod N, 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 5 times you are going to print this one. This I loop, how many times you need to perform this? Number of elements. Okay. See, this E indicates what? Your public key. So that's what. So your formula using, see, encrypted of 5. How much it is? 1. 1 star. Num message of I, num message of 0 is how much? 8. 1 star 8. Modulus of N. How much I got? 7 3 is 20. 21 I got, right? 1 mod 1 into 8. 8 mod N I'll get. Again, same thing. 8 mod N. 8 mod N. This is 5 times it repeats. 8 mod N, 8 mod N, 8 mod N, 8 mod N, whatever it is. That you'll get. So that's what here I've calculated. I'll show here. But 8 power 5. E is 5, right? 8 power 5 mod N. Means 8 power 5 mod N means 8 power 5 is 32768 divided by 21. However, how to calculate mod function I'm saying? 1560. 1560 into 21, 32760. Means 32768 minus 32760 is how much? 8. How much you're getting is 8. So here in your program, what happens is, you're getting what? Encrypted of I. And the encrypted of 0, how much you got is 8. And for which one? Yeah, for your H value. And then what you will do is, you are printing it. Encrypted message. How do you print? Encrypted of I. Again, see, character encrypted of I plus 96. Encrypted of I. Encrypted of 0 is how much? 8. 8 plus 96 is how much here? 104. Again, you're using your typecasting. So character and character. So this is your I is what? Integer. So 8 plus 96 is how much here? 104. 8 plus 96 is what? 104. 104. What is the ASCII value of your 104? H. See, 8H. So that's what it prints. that what it prints whenever you give. See here, I'll just give high, and the prime number I'm giving 7 and 3. Now here for h value you got how much? 8h. That's how you're getting. In the same way, if you want, you can check for I value. Yeah, I value how much you're getting is 18R you're getting. I value how much you're getting is 18R. So here in your program you can just see. Okay, here. Now what you will do is, for what is the ASCII value of your I is 105. 105 minus 96 is 9. So here what you will do, you will apply here. 9 power 5 modern. 9 power 5 modern. So here also it is 5. So 9 power 5 modern. 9 power 5 modern. 5904. 9 power 5 is 59049 divided by 21. That is 2811. 2811 into 21 is 59031. So 59049 minus 59031 is 18. That's what you get here. So this J loop indicates how many times you want to perform. This is encrypted of 5. Encrypted of 5 is 1 into num message. How much you got? 9 into modern. So that's it. 9 power 5 modern. So 5 times you're going to repeat this. And the total result, whatever it is stored in encrypted of 5. Okay, encrypted of 5. How much you got according to this? You got 18. You got 18. So next what you will do? Character encrypted of 5. That is 18 plus 96. How much you'll get? 18 plus 96 you calculate. 18 plus 96 if you calculate, how much you'll get is 114 you'll get. So 114 is how much? R. 114 is how much? R. So 18R. That is what it is printing here. In the output what happens is that's what it is printing. So that's it. See, that's what it prints, decrypted message. So hope you're clear. So for GCD calculation, I'm using this one, not GCD. Two values you're entering, while n is not equal to 0 or m modulus n. So m is equal to n is equal to r. So this is used to calculate your GCD function. That's it. Hope you're clear with this. So as I said that higher the prime number, more it is secure. And here one more thing. So I'll give, enter the message. I'll give Suhas and I'll give 7 and 3. I'm not getting it properly. Why? Because 7321. The total number of characters present is how much? 26. So the product of two numbers, whatever it is, it should be more than 26. 7321 andre only it will convert up to what? Only it convert up to your U stay. WXYZ did not be converted. So that's why what you do is also share. Higher the prime number, it's going to convert everything. I'll just keep Suhat itself, but I'll give prime number 11 and something I'll give 3. See, it is converted. 11 is 33 and then it converts everything. Hope you're clear with this. So 11 3 I gave, pi value 20, E value you see 3 you got, D value you got 7. So this what happens is it's very small it is. So I said higher the prime number, more secure it is. So just you give Suhas is good. Okay. So I'll just give prime number something like 111 and 1 23. So probably that is not prime number. Higher prime number you give, that's it. Suhas is something like 1 so not taking 1 second. I'll just give 11 and 19 only. Yes, Swatch is good. So D value, how much you're getting? 103. Only for 11 and 19 only D value is 103. So convert it to some other format. See, Swatch is good, but just see the encrypted message. Even though hacker is going to see the message, he's not able to understand what the message is. That's it. Again, decrypted message, Swatch is good back. Hope you are clear with this. So this is your RSA program, your LabSec program. Hope you are clear with this, guys. Okay. So that's about your RSA algorithm. Thank you. Hope you understood the problem. Okay, here I'll stop your program.